something alerted me to that, something happened. So once I realized that, and then I noticed this component here at the other line, because these are the two lines I was looking for, I realized that something really exciting might be happening here because I've got two new components all sitting on at once. Flares are interesting. It means something has exploded. Okay, and in star formation parlance, that means something could be born. Okay, so you do see lots of variability in these things, but you don't normally see a new component turning on at the same velocity as these two here. And then that little bit right there in the middle of the ground station. And then, luckily for me at our trail, we had started observing monitoring programs looking at these squiggly lines. We've been doing it for 25 years. Now, I left astronomy. I went into business for about 20 years. I fired people for a living. Not a very nice job, I can assure you. And they tried to throw me in prison once in Angola, and I decided to go back into astronomy. It's safer. So I came back into astronomy where it's dull and boring, and I could be happy and out of prison. You know, so life can be dangerous. So if you want to stay out of prison, join astronomy. Okay, whatever. But so the upshot story is, well, what then I realized was at Hartria, we monitor these sources all the time. Every 2 weeks, we've been doing so for 10 or 15 or 20 years, depending on the source. And this source, lucky for me, has been looked at since 1999. I detected it originally in 2001. And you can see here, there's nothing really fancy happening, and then this all turned on. So that blank turned on. Nothing there, turned on. Nothing here, turned on. All of this is new. Now this is even more exciting. So now I can look at the data from 1999 through to today, and I can make monitoring maps. So remember, I'm a detective, right? I've noticed something has changed. I'm looking for a difference. There's a difference. I don't know what the heck has caused it. I don't know why it's caused it. I don't know when it's happened. But I know it's happened. Okay? So now I say to myself, now it's happened in other transitions. And by the way, this is the first time ever somebody has seen this happen in 3 different molecules at the same time. So this in itself was pure, it was pure luck in the end, quite honestly. But it was exciting because 3 different molecules were doing something interesting at the same time. And it could either be aliens, but it could be most likely a star being born. So let me move on. And so here's monitoring. So here's, you can't see this very well, but here's February 14, 2014, August 2014. And you can see nothing is going on for 2 years, and then wham, it turns on. Okay, so this is a light curve. So this is the strength of the peak, and this is when it turned on. Okay? And it turned on here for water, it turned on here for hydroxyl, it turned on there for the other methanol lines. And here I only noticed it after, because I wasn't monitoring these before. So these are all dying away now. So they're already on the bottom side here, like that. So what it tells me is I'm now looking at this source in 10 transitions, and it takes me 2 weeks to observe all this. So I have to do an hour observing on every single transition, and I can only do it when the source is directly overhead to make sure I minimize the errors. Okay? And I observe that source every 1 to 2 weeks at 10 or 12 transitions, and these are just 1, 2, 3, 4, 5, 6, 7, 8 of those transitions that are being done. And you can see they're all varying at roughly the same rate. So again, as a detective, I've now got 2 pieces of information. Something new is turned on, and over time, they've all turned on at roughly the same time. In outer space, if it turns on at the same time, it's because it has to be a radiative event. It has to be photons. They travel at the speed of light. If it takes a long time, a big gap between them, then it's a shock front. So that little piece of information in my head is, it's a radiative event. So I've got an explosive event occurring here. And in a star forming region, again, an explosive event could be things like, I don't know, the star gives off a big burst of radio waves or whatever, all sorts of funny things that I can't figure out exactly what it is. But I can tell you that on the 13th of January, this star was born. I know the exact date that this event occurred. So Kitty, as I refer to her as Kitty, because in the Cat's Paw Nebula, if it was a cat being born, it's a kitty, right? So this is Kitty. So anywhere around, I know it's the 13th, but I round it off to the 15th of January, plus or minus 5 days, is the birthday of this star being born. So either a star was born, or it's converted from one condition to another, but something happened on the 15th of January. And then I go to other telescopes. So I use VLBI techniques, very long baseline interferometry. Remember, Australia and South Africa. And then what I do is I actually look at the previous data, which is here. So you get this is methanol done by a telescope in Australia. So you got those three components, 1, 2, 3. They are actually this, this, and this. But there's nothing up here. That's all of this. This is Kitty. So Kitty resides in this area right there. So that's all new. Now that has never been seen before. So I got something interesting on my single dish. I realized I need to look at it with other telescopes. The guys in Australia said happily they'll look at it for me, so they re-observed. This was done in 1996. This is done in October of 2015. That's all new. So I know this turned on in October because I'm monitoring the source. Okay, I monitored single dish, and they can show me where. So this, I tell them the when, they tell me the where, and then what it is the next question we don't know. This is ALMA, that telescope in the desert at 5,000 meters above sea level. It's a millimeter telescope, and this big bright spot turned on. And lucky for us, the Americans were observing this source at exactly the same time my source was peaking. And it wasn't because they thought there was something there, they were just re-observing something they had done 10 years ago to look at proper motion. So we got lucky. So the Americans were doing something the same time I was doing something, and so we all got lucky. So now the two groups are now working together. So we're sharing our resources, and in astronomy that's a very common thing, to share data, to share resources. And it will be no different in Tanzania. So you share your telescopes. And so that component there is the dust. It shows you the dust temperature. And that white spot, the dust got 60 times brighter between 2006 and 2016. So we know something happened, we just don't know when, but my monitoring data tells them when. So I can go back 10, 15 years. Anyways, so that is where Kitty is. Kitty happened on the 15th of Jan 2015, and this tells me the dust got bright. The only way you can get that much energy is if something blows up. So either a star is born or a star blows up, otherwise you can't form it. So as a detective, I'm down to one last thing, and I got to figure out the difference between is it a star blowing up or is it a star being born? That I don't know yet. So I still have to look at this again. So if I look at this again, and they are now re-observing, if it disappears, then I know it was a star blowing up. If it stays there, it's a star being born. And then we will have watched the star being born, and that to me is exciting. Okay, now there's one last piece of information that Kitty showed to me just on Thursday, which surprised the hell out of me, quite honestly. And I can't even explain it still. It's this. Does that look periodic to you guys? Does it look like it's in a period? It's about 300 days between here to here to here, and then these are 300 days apart, but they're completely anti-correlated. So you can see the blue line is actually getting bright first. Well, it doesn't matter, you can start at the red line if you want, but they're anti-correlated. They're completely 180 degrees out of phase. I cannot explain this. I don't know what's causing this. This does not make sense to me. I should not be seeing this. So I don't know if this is real. I don't know if this is an artifact of my observing. And I don't know if it's not aliens. So it could be aliens sending out a signal saying, you know, danger, you know, who knows? And then something happened. And here's where the event occurred, right there, and you can see it's now getting brighter. So the signal started getting brighter through that event. So this was just found on Thursday, and I cannot politely explain this. I have no idea what causes that. To see anti-correlation, think of something going like this, flicking up and down like that. That's what it's doing. It's like your headlights flicking. Just at least, I saw the first lines on Thursday, this one here, the blue line, and I thought that's really exciting. It's periodic, because we were looking for periodic mazes in these long-term monitoring. And then I thought of plotting all the other lines around it to see if there's any differences, and I found this one immediately. And it's anti-correlated. And so I can't explain that. I don't know how to explain it. So I have to figure out a model to explain that. So now I'm back to my detective work again. So the more I look, now I think I've seen a star being born, which is exciting. Suddenly I'm looking at something that I can't explain, and now I need to look at it with other telescopes again. So now I got to start asking the Americans, asking the Australians to look at this again for me. Okay? So this is the science we can do from these things, and this is astrochemistry. This is really just astrochemistry. Okay? It's not anything more than spectroscopy. It's the same as you do in your chemistry labs. So that's the exciting part for me. And that was my 1% excitement for this year. So now I'm going to be boring for the next 12 months until I find something new, if I'm lucky. And I got to tell you, to find 2 things like this within a year, this is the chance of a lifetime. For any astronomer like myself, these 2 things was a dream come true. To watch a star being born for me, it's something my supervisor and I talked about 25 years ago. So I just got lucky. I just happened to come back into astronomy at just the right time, and I happened to be at the observatory where I could look at all this data that was being monitored by my friend, had been doing it for 20 years after he and I left and he carried on. So I just got lucky, okay? But there's no chance of a Nobel Prize in all this, don't worry. So, and it doesn't come into my head. Although people have said it, and I'm just looking at people, don't be stupid. Let's be serious here, right? This does not change the nature of the universe, how we understand it. It does not. But it is kind of cool. It is kind of cool to say that we actually watched the star being born. Because now we can say definitively what might occur when the next one happens. Now we know what to look for. So what is interesting to me is how we change how we observe. So, for example, there are, as I said, 8 transitions on that thing. A telescope, and this is the part that's really crazy. A radio telescope, you tune it to this frequency and you use one frequency at a time. Then you have to stop observing, you have to retune it, and then you do observing over again. But the signals from outer space, they all come at the same time, don't they? Signal from outer space, it doesn't care that your telescope is tuned to 1665, the one on the far left, or 6030 on the far right. You get the signal automatically. So now we're trying to change the way the telescope operates. So just because of these observations, Hard Trail and telescopes around the world are now going to change how they observe. They're going to now try to do simultaneous observing at all frequencies, because we're obviously missing out on a lot of science. So when you do astronomy, and hopefully when they build a millimeter telescope, they also have broadband receivers that you can get all of the data instantaneously, simultaneously. And that's the key to life. And so what's interesting to me, forget the Nobel Prize, is that they're going to change the way they observe because of this source. To me, that's interesting, because it means that we can do new and better science. So that's kind of exciting to me. That part makes me feel like I'm been a part of something. I've actually helped people. And if I can help them put a telescope at a great site in Southern Africa, I'll also be very happy with that as well. So here is, as I said, I wish I could explain it. I wish I could tell you what it is. I have no idea. And I'm still thinking this is aliens. So if you guys think I'm crazy, if you think I thought I was crazy before, now you think I'm even more crazy. And this source, interestingly, 20 years ago, I had a discussion with my then boss, the director of Hard Trail, when I first started astronomy as a young